Unit 5, Lesson 3. So we're going to take another look at compound interest. There's a little typo on your note. Make sure you fix your typo. Rather than use a chart, it says a formula. Rather than use a chart, change that from formula to chart. Rather than use a chart like we just did to determine the amount for compound interest, we can use a formula that does the same thing, so we don't have to have a whole table full of information. The formula, once I get my board to work, here we go. The formula is A equals P bracket 1 plus I is the exponent n. A is the amount of the investment in the future. So instead of adding on the interest every time like we did in the table, this formula will figure that out. P is the principal investment invested. I is the interest rate per compounding period. And n is the number of compounding periods. So that's basically talking about how often interest is calculated. So how often the interest is calculated is determined by something called the compounding frequency. If we look at this table, we can have different types of compounding frequencies. We can have annual, semi-annual, quarterly, monthly, daily. An annual compounding period, of course, is once per year. A semi-annual is twice per year. Quarterly, 4 times, monthly, 12 times, and daily, 365 times, once each day. So if you have an interest rate spread out over the whole year, if you compound it twice a year, you have to take that interest rate and split it between the 2 times that you're calculating interest. So you take the total interest and you have to divide it by 2. Now, if we only compound once a year, we're doing the same thing, but I divided by 1, or anything divided by 1 is the same thing, so it doesn't change it. But if we compound interest 4 times a year, we have to take our interest rate and divide it up into 4 equal parts. Or 12 times a year, we take our interest rate and divide it up into 12 equal parts. And so on, depending on how many times we compound. The time frame, if we calculate interest annually, nothing changes to our end value. But if we calculate interest twice a year over, say, 3 years, we would do it 2 times each year. For 3 years would be 6 times. So you've got to take your n and multiply by 2. Or 4 times a year would be your number of years times 4. Or 12 times each year, your number of years times n. Or 365. So you're getting the idea. To adjust n, you multiply by your compounding frequency, and to adjust I, you divide by your compounding frequency. Let's take a look at this formula. Be careful using this formula because it calculates the amount plus the interest, unlike simple interest that just calculates the interest. So if you want to know your interest only, you would have to take your answer and subtract the principal you started with, and that will tell your interest only. So if I look at my first example, determine the future amount and the interest earned for each of the following investments. The amount is the principal, $1,500, times 1 plus my interest rate compounded annually, so there's no adjustment when it's compounded annually, it's the exponent 10. And then you type that directly into your calculator and get an answer. So I'm going to type exactly in 1,500 times bracket 1.05 bracket to the exponent 10. And I get an answer of $2,443.34. Okay, so we have calculated the amount we started with, the principal plus the interest. So that's the future amount, $2,443.34. The interest earned, however, to get the interest, you have to take that amount and subtract the principal. So my interest earned, when I subtract those two numbers, is, oops, 2,443.34 minus 1,500, $943.34 in interest. So the whole key is to making sure you use your formula correctly and understand that it is the amount plus the interest. Get rid of that thing. There we go. So to figure out my future amount, I've got my principal, invested for 5 years at 8%, compounded semi-annually. That means 2 times each year. So I'm going to have my interest rate split between the 2 times each year. So 0.08 divided by 2. And I'm going to have my time multiplied by 2. Because 5 years twice a year would be 10 times for the 5 years. So 1 plus 0.04 to the exponent 10. And we can figure that out to be 2,000 times 1.04 to the exponent 10. So we have an accumulated future amount of $2,960.49. To get the interest, take the amount and subtract the principal. So we had $960.49 in interest. Next one, 5,000 compounded quarterly at 9%. So the amount is our principal times 1 plus 0.9 divided by 4 and 12 times 4 to get my exponent. So 1 plus 0.09 divided by 4, 0.0225 to the 48. So I've got 5,000 times 1.0225, the exponent 8. So we would have $14,548.20. So that's the amount accumulated. The interest earned would be that amount minus the principal we started with. So we have got $9,548.20 in interest over the 12 years. Last one. The future amount is the principal times 1 plus the interest rate divided by 12, because monthly is 12 times a year, for 15 years times 12 times each year. $0.6 divided by 12, 0.005 to the exponent 180. So our future amount is 1,000 times 1.005 to the exponent 180, $2,454.09 is going to accumulate. So my interest will be $2,454.09. Take away the 1,000 I started with, so I've earned $1,454.09 in interest. So the compound interest formula, as you can see, is much nicer to use than to have to fill in the whole table to find your accumulated amount. So you can try those questions now on page 433.